Greetings, fellow nerds. Today I want to talk to you about the derivative of an inverse function. There's actually a really neat way of thinking about this derivative, and so I'll go through this derivation, but very little is needed to be known in order to arrive at this result. You will need to know the chain rule and a little bit about inverse functions and their behavior, but outside of that, it should be pretty straightforward. So without further ado, let's go. I think the way I want to approach this is just, again, this video is really for those that are newer to calculus. So just imagine that the inverse function itself, let's just call it y, for instance, right? So if I'm looking for the derivative of an inverse, then that means I'm looking for dy dx, so to speak. Like these two are one and the same thing, if that makes sense. And so that'll be helpful when we are thinking about our goal. So our goal is to find dy dx if y is the inverse function of x. So seems like a small thing, but it actually will transcend to, I think, a wonderful moment later on. So let me show you. Anyway, so we have this. Here's what I'm going to do. I don't really know much about this inverse. And again, this is an arbitrary inverse function. But what I can do is take, I'm going to apply this function's inverse function, so to speak, to both sides. That being said, f is the inverse function of f's inverse. A little bit of a tongue twister there. But that being said, I'm going to do that because obviously these two undo each other and you're simply left with x. And so the left side, of course, we just get f of y. But I'm interested in the derivative of this equation. So what I do to one side, I have to do to the other. Now, if you've never seen implicit differentiation before or ever heard of that, that's fine. You don't need to know anything about that. What I just want you to realize is that y is a function of x, and it's obviously inside of f, which is a function, right? So you have a y, which is a function, inside of f, which is a function, so that's a composite function. So if we want to differentiate that, it's simply chain rule, right? So here we go. Let's bring that out of context. So our outside function is f, our inside function is y, and so differentiating our outside function, pretty straightforward, is f prime. And differentiating our inside function with respect to x is just dy dx. There's really no other convenient way of writing it, so it's just dy dx. So here we go. Chain rule would say that the derivative of that composite, f of y, would be the derivative of the outside, leave your inside function alone, times the derivative of the inside. And of course, the right side of this equation here, the derivative of x with respect to x, is simply 1. So that's really nice. But remember, if our goal is to find dy dx, we have an equation with dy dx in it. So we can just divide the f prime of y over, and there we are. And so, looking at this as our derivative, that's really just it. There's one really neat thing, though, and that's, remember that y itself is the inverse function of f. And so I can replace that y here with the inverse function. And now we have a very convenient way of thinking about the derivative of an inverse. So if you want to see this formula in action, stay with me on a future video, but I wanted to show you guys where this formula that you see in your textbooks or your calculus teachers are showing you come from. And as always, take care, nerds.